हो गई अटेंडेंस लिस्ट ऑलरेडी, ठीक है। ओके, सो डू यू नो व्हाट अ ट्राई स्टेट बफर इज? Anybody have any idea about tri state buffer? Please turn off your microphone. Please turn off your microphone. G. So what a tri state buffer is? Anybody has any idea?
No, sir.
You may have studied in electronic design tri state buffer.
No, sir.
No,
Okay.
sir.
Okay, so now let me explain it. So a tri state buffer is a device. So now let's assume this is a tri state buffer. This is our tri state buffer. It has one input and output and control terminal. So there are three terminals of a tri-state buffer: the input and the output and the control terminal. Okay, so the output, so there are three possibilities. So when the control is 0, so in the control it will act as a switch. So when the control is 0, so when the control is 0, so if you say that if the control is 0, so control is 0, so actually the output will be tri-state. And what's a tri-state? जी बताएं, कोई बता सकते हैं what is a tri-state?
Sir, three state.
No, tri-state. Tri-state is it is also called as tri-state or high impedance state. High imp. What is in high impedance state? जी बताएं. So the output is a high impedance state, and when its output is high impedance, so high impedance means high impedance state. It is neither a logical one nor logical zero. जी, हाई इम्पीडेंस से क्या मतलब है?
डोंट केयर भी कह सकते हैं फिर।
No, it's not a don't care. No बेटा, no, it's not. Don't care is a different thing. Don't care means, अच्छा अब मैं अगर मैं कहता हूँ, अच्छा दिर इज आपने बेटा है जो सवाल किया इसको मैं थोड़ा सा कंफ्यूज कर दूँ. Don't care means it is either a logical one or logical zero, but we ignore this value. बेटा समझ आ गई या नहीं आई?
यस सर।
अच्छा मैं I will explain this with an example. Let's assume, अच्छा let's assume there is I'm teaching you in the class, okay, and one student has raised his hand, ठीक है, it means it's a logical one, and the student who has not raised his hand, it means it's a logical zero. अब बेटा समझ आ गई या नहीं समझ आई? ठीक है, and if a student has raised in his hand, so it means he's asking me a question and I'm ignoring him. I'm not replying and I'm doing. This means that it's a don't care. Let's assume that 15 students have raised their hand and I'm not even considering them. So it means it's a don't care. बेटा समझ आ गई या नहीं आई समझ?
यस सर।
Don't care means that x, it means x. So there are two possibilities for the value of x. So x is either 1 or 0. But what's a high impedance state? What's a high impedance state? बेटा बताएं.
सर इसकी वैल्यू वन
Sir, na zero na one.
ना 0 है ना 1 है, कोई भी वैल्यू
Yes,
नहीं है. It means that okay, it means there is no driver on the bus. No driver on the bus. These are logical 0, logical 1. आपने कभी logical probe पे काम किया है? Did you work with a logical probe?
सर अगर इसकी कोई वैल्यू नहीं तो
Yes, sir.
इसकी क्या इम्पोर्टेंस है?
No, sir.
अगर 1 है तो इसका मतलब है LED रेड होती है, अगर 0 है तो LED ब्लू होती है. लेकिन when there is knowledge तो LED is blinking. It means there is no signal, nothing, no value, neither a logical 1 nor a logical 0. बेटा समझ आ गई या नहीं आई समझ? अच्छा, now I will again explain this with some many examples. Now let's assume that the value of control is 1. So the value of control is 1. So the output out will be equal to n. Okay, now let's assume there are two possibilities. When n is equal to 0, then what will be the value of output? Out will be 0. When n is equal to 1, then out will be 1. It is actually acting like a switch. It is acting like a switch. So it is acting like a switch. So it means that now when control is 0, so I can also draw it here. So when control is 0, so now this is in and this is output. So the output is it is acting like a switch. So output is disconnected from the input. So when the output is disconnected from the input, so we call this state as kya state hai? What is the name of the state?
Control 0.
No. When control is 0.
So
When
high
control
impedance
is equal
state.
to 0.
High impedance state.
So the output is also called as a tri-state or high impedance state. Now there is another possibility. So now let's assume when control is equal to 1, so this output will be connected to input. And what will the value of it? When n is equal to, now there are two possibilities. In can have a value. In either can have value of, so there are two possibilities. When n is equal to 0, output will be equal to 0. When n is equal to 1, then output will be equal to
1.
Okay, now in which scenario, now we will also study that in which scenario the tri-state buffer is used. The tri-state buffer is used to connect multiple devices. Tri-state buffer is used to connect multiple devices to a single line. So I will now explain this with an example. So now I'm going to explain this with an example. Now let's assume there are two devices. Now what we are going to do, so now here is a tri-state buffer. Now enable is equal to 1, enable 1, it's enable 1. And this is in 1 and this is out. Now we have another device. It is, please turn off your microphone, please. In 2, and it's also connected to the output. So it means that which input will be connected to the output will be determined by the signal En1 or En2. So now there are, if you look at this possibility, so there are possibilities in 1 and out. Okay, now we tried 18. Okay, now the first possibility, when n is 0, enable 2 is 0, what will be output? Ji bataye beta. In this example,
High impedance.
high impedance. No, high impedance. Why 0? High impedance. Because both switches will be disconnected. And both switches will be disconnected. So actually, what will be the scenario? So in this scenario, the first switch is also disconnected, the second switch is also disconnected. So the output will be high impedance. Okay. So now when enable is equal to 0,
control 0 है sir इन दोनों के लिए.
जी enable 1 is also 0, enable 2 is also 0. In this particular example, I am trying the truth table. समझ आई बैठी या नहीं आई बैठी?
Yes sir.
When enable 2 is equal to 1, then what will be the output?
Into.
High impedance.
No, into. Why high
Into.
impedance?
Into.
Because the second device is enabled. So which device will be connected to the bus? The second device.
Second
Okay.
second device.
Okay. Now if enable is equal to 1 and enable 2 is equal to 1, which device is connected to the bus or the output?
In 1.
Device
Input
1.
In 1.
Okay.
Device
Now-
1, sir.
Yes. Now there is a problem. if both are 1, what will happen? E.
No,
Undefined.
sir, कोई आंसर नहीं है। Undefined.
No, undefined. Yes, actually in this is undefined, and I will also explain that why this should be undefined, and sometimes there will be a problem. Maybe there is a short circuit. I will explain this now. Why there will be some. It's also possible. Okay, now undefined, and actually being as a designer. So being as a designer, you should avoid this case. Being as a designer, you should avoid this case because no two devices can draw the bus at the same time. And I will explain this why. Now let's assume a scenario. So now we are talking about a scenario. Now let's assume a scenario. So we have a scenario like this. Okay. So the scenario is something like this, that both are enabled. When both are enabled, so now it means that this will be connected. In one will be connected to the bus. Am I right or not? And then enable 2 is also connected to the bus. Now it is your output. And let's assume scenario. This in one is driving a logical 1. And this in 2 is driving a logical 0. What will happen? Ji beta. Which value will be on the output?
And 1, sir.
1, sir.
है? अब आप लोगों ने इलेक्ट्रॉनिक्स नहीं पढ़ी? Did you study circuit analysis? Circuit analysis पढ़ी है या नहीं पढ़ी आप लोगों ने?
पढ़ा है सर।
पढ़िए सर।
हाँ, तो फिर क्या होगा? When you short VCC and ground, what will happen? When you connect VCC with the ground, with no resistance.
Ground, sir.
Sir, short circuit हो जाएगा.
Very good. Who said this? What's your name, beta?
Sir, Abbas.
Sir.
Abbas, very good. So basically, it will be something like a short circuit. Why there will be short circuit? Now, when the device is connected, it means it will have a very low resistance or something near to zero resistance. So now let's assume you have a VDD. Okay, now you have a resistance. Now you have a ground. Okay, now this VDD is actually in one. And this ground, because now you are connecting both. This is actually in two. And the resistance is near to zero. So what will be the current? The current is equal to voltage difference, V diff, divided by R. What is V diff? What is V diff, beta?
Voltage difference.
Voltage difference. What is the high voltage? VDD
minus 0
divided by R. And what is R now? Because when it is connected, so something
nearly 0.
Nearly 0. So this will be a very high current. When there is a high current, so it means it may be a short circuit. Better समझ आ गई बात ये नहीं? High current means near to infinity, yes, because sir. No circuit has a very zero resistance. Something is, at least we can have some resistance. So that's the reason when you are connecting multiple devices to the output, so you should make sure that two devices should not be enabled at the same time. समझ आ गई बेटा या नहीं आई? You should make sure that two devices should not be enabled at the same time. अब बेटा समझ आ गई या नहीं ये जो मैं आपको समझा रहा हूँ?
Yes, sir.
आ गई.
Okay, very good. Now we will study this in the context of bus. So whenever now we are connecting some devices. Now what we want to do, because this topic is relevant to memory system design. Okay, when we are using memory, so for which purpose we are using the memory?
Sir,
To store some data. Okay, it's very good. You said it, to store some data. But when we store some data, which type of operation are supported by memory? कौन से ऑपरेशन है supported by memory?
Read and write.
Very good, read and write. So we want to support read and write operation. So now I will study. We will study this in the context of the tri-state buffer. How memory and microprocessor will look like. Okay. So then now I will explain this. If you look at here. Okay. So now we can have a look at this in the notes. Okay. What are these devices? Can you see the device 1, 2, 3, 4, 5, 6, 7, 8, 9? जी स्क्रीन नजर आ रही है बेटा आपको?
Yes, sir.
जी सर.
Yes, sir.
What is this? What is this?
Yes.
What is this?
Operation
In the
amplifier.
group. No, operation. What? Why operation amplifier? अभी मैंने आपको क्या पढ़ाया बता के बंदे? अभी मैंने क्या पढ़ाया आपको?
Tri-state buffer.
Tri-state buffer. So this is a tri-state buffer. Actually, this is a tri-state buffer and it is not shown. So now we have enable one. The enable is not shown for simplicity. Three terminals है. कितने terminal है? यहाँ पे नजर आ रहे हैं कितने terminal है? 3 terminal है ना?
Yes.
This is a
Yes, sir.
And now we also have this enable. यहाँ पे क्या होगा? Enable 4 होगा ना? If you look at tri-state buffer 4, tri-state buffer 4 नजर आ रहा है?
Yes, sir.
अच्छा, do you see the tri-state buffer 4? If you look at this tri-state buffer 4, actually this tri-state buffer 4 is the output to the memory. ठीक है? अच्छा, इसका एक enable भी होगा. ठीक है? Every tri-state buffer. How many tri-state buffer are there? बताएं, कौन से कितने tri-state buffer है?
9.
There are 9 tri-state buffer. Okay, so there are 9 tri-state buffer. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 tri-state buffer. Each tri-state buffer is an enable. Each tri-state buffer has an enable. Okay, now let's assume a scenario. We want to perform a read operation. So we want to perform a read operation. What will be the direction of the data? From memory to microprocessor or from microprocessor to memory? ये बताएं बेटा. बताएं ना बेटा. We want to
Memory
read
to
some.
Memory to microprocessor.
Yes. So the direction of the data will be from memory to microprocessor. Which tri-state buffer will be enabled? ये बताएं.
Fourth.
No, from the memory to the microprocessor.
6.
6. Very good. Very good. 6. The direction will be something like this. नहीं समझे बेटा? समझ आई बात या नहीं आई?
Yes, sir.
अच्छा. Now we also want to place some address. We also want to place some address at the address lines, because when we want to access the memory, so it means we want to place some address. So actually address can be placed on this address line. So microprocessor will provide the address. Okay, now we have a single bus. Bus can be connected to only one device. So if you look at the bus, so actually this bus is connected. If you look at the data lines bus, the bus is connected with tri-state buffer 2, tri-state buffer 6, tri-state buffer 5, tri-state buffer 3, tri-state buffer 7, and tri-state buffer 8. If you can see this, but only one device should be driving the bus. Okay, so which tri-state buffer will be enabled for the data lines? कौन से tri-state buffer enabled होंगे? ये बताएं. For the data lines. जी बताएं.
2.
2 will be enabled. And which will be enabled? 2. and 6 are enabled. And which one will be disabled? Five will be disabled. 3 will be disabled. And we also don't want to connect the IO device to the bus. So set 7 will be disabled and 8 will be disabled. This is for the data line. What for the address lines? Address lines, if you look at this, so IO device can also provide the address to the memory. Okay, so which tri-state buffer are connected to the address lines? 1, 4. So this is for address lines. Now for address lines. So now we have an address lines. Which will be enabled? That is shown in yellow. Which will be enabled? 1
and 4.
And 4 will be enabled. And which will be disabled?
7.
No, it is 9. Actually, if you look at here, it is 9. 9. 1 and 4 will be enabled and 9 will be disabled. जी समझ आ गई या नहीं आई? अच्छा, now this is the read operation. So this is a read operation. So who is reading from memory? Who is reading from memory? ये बताएं.
Processor.
Yes,
Processor.
microprocessor. So this is a read operation with respect to microprocessor. But if okay, now let's, so it means that this is a read operation with respect to microprocessor. Now let's assume a scenario that the IO device is want to read operation. IO, now we have an IO read. We have an IO read. फिर क्या होगा? Scenario क्या होगा बेटा? समझ आई बेटा या नहीं आई बेटा? हाँ जी. अच्छा, now what I am going to do, so now let's, okay, now what I am going to do, this is the fourth page, this one. Explain this. So now I'm currently printing it. Print. Current page. What I am doing to this Microsoft Print to PDF. Okay. Now I'm printing this page. Just for, so now we shared with others. 2 students, embedded systems. So now we have this memory. So now what I can do here, memory 1, copy, Control V, rename. Name. Okay, now what I'm going to do now, open with. Okay, अब बेटा मैंने थोड़ी सी नई कर दी ताकि आपको और समझ आ जाए. अच्छा, now let's assume a scenario that we want to now. So I wants to read the data. I read operation. जी बताएं. Which tri-state buffer will be enabled? जी बताएं. आवाज नहीं आ रही बेटा.
सर
क्या कह रहे?
सर इनकी नंबरिंग कर दें ट्राई सेट बफर की.
यार नंबरिंग ऑलरेडी हुई है बेटा. ये इज 1.
नजर नहीं आ रही.
नजर नहीं आ रही. अच्छा, चले अब मैं आपको बताता हूँ. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8 and this is 9. चलो अब बताएं बेटा. चलो अब तो आ गई ना या नहीं समझ आ गई? नजर आ रही बेटा?
Yes, sir.
हाँ, अब बताइए. I want to read from the memory. Which tri-state buffer will be enabled?
7.
7 because I want to read. So actually this 7 will be enabled. यहाँ पे direction ये होगा. Direction will be like this. And I want to read. Which other tri-state buffer will be enabled? जी बताएं.
Sir, 8.
6.
6.
6.
6.
Yes. Yes, 6. 6 will be enabled. So the direction will be from the memory to I. So that okay. So if we want to perform an I read operation, so the direction of the data, the direction will be from memory to IO. Which tri-state buffer will be enabled? 6 will be enabled
600.
and 8 will be enabled. जी अच्छा अब बताएं 6 and 8 will be enabled. Which will be disabled? Because they are connected to the data lines. कौन-कौन से data lines के साथ और
Sir, 2.
2 2 3 because when microprocessor is not reading the data तो 2 3 will be disconnected because microprocessor
6 और 7 नहीं होंगे
in this
enable.
scenario all of this will be disabled because IO wants to perform the read operation, so it means all the tri-state buffer will be microprocessor will be disabled. It's so simple. Okay, so 2 3 will be disabled and
5.
5 and 8 will also be disabled. Okay, so 5 and 8 will be disabled. ठीक है. अच्छा, now this IO
Excuse me, sir.
should
सर
give it.
ऊपर ने 8
सर
भी
यहाँ
आपने
पे 6 और
इनेबल
7
किया हुआ
नहीं
है.
होगा.
क्या कह रहे हैं?
7 होगा.
6
6
और 7.
6 और 7. देखिए, now you also want to have the direction of the data. Direction क्या होगा? Direction तो actually tri-state buffer होगा तो actually direction should be like this, not in the opposite direction. Why 8? 8 जो है ना वो तो opposite है, वो तो reverse bias हो जाएगा ना. नहीं समझे बेटा?
सर आपने 6 8 की जगह 7 लिखना था.
Oh yes, you're right. Thank you बेटा. तो now आपने बिल्कुल सही कहा.
सर ये कोई बार-बार अनम्यूटेड क्लियर आ रहा है.
क्या कौन कर रहा है?
पता नहीं सर, वो 5 मिनट बाद जब मैं क्वेश्चन पूछने लगता हूँ
अगर
कर देता है.
किसी ने अगर अनम्यूट किया ना तो मुझे उस बंदे का अगर नाम पता चल जाए सिर्फ मुझे नाम बता दे, आपको 5 बोनस
सर
मार्क्स मिल
आप किसी को अनम्यूट नहीं कर सकते सर. पॉसिबल ही नहीं है किसी को अनम्यूट करना. आई डोंट नो ये कैसे कह रहे हैं.
बच्चोली हरकतें ना करें ना. बड़े हो गए आप, कितने बड़े हो गए, प्लीज. ठीक है. अच्छा, प्लीज डोंट disrupt. अच्छा, now we want to perform an IO read operation because then IO should provide an address. So which tri-state buffer are connected to the address lines? Ji, which tri-state buffer are connected to the address lines?
9 sir.
9 and then
4.
9 4 and 1. 9 4 and 1 are actually connected to the address line. So which will be enabled? Which of them will be enabled?
9 or 4 sir.
9 and 4 will be enabled. So IO will provide an address. So the address will be provided from this direction. So actually from the address lines, so 4 and 9 will be enabled. And which will be disabled?
1 sir.
1 will be disabled. Very good. I'm also saving this. मैं यहाँ पे save कर रहा हूँ. I'm saving this, and you can find this this scenario. Oh, now let's assume another scenario. So okay, now I'm studying. So now let's assume another scenario. Okay, now let's assume another scenario. Now we want to perform a write operation. So the scenario is we want to perform a write operation, and who wants to perform a microprocessor wants to perform a write operation. So Jay, which tri-state buffer will be enabled?
So 3.
Mm-hmm. Yes, 3 and
5.
3 and 5. Okay, 3 and 5. Microprocessor want to perform a write operation. 3 and 5 will be enabled. Okay. Now from the address lines, or from the perspective of address lines, so microprocessor will provide the address. And then, so which tri-state buffer will be enabled?
1 and 4.
Okay, 3 and 5 will be enabled. Okay, when in this scenario, all the tri-state buffer will be disabled from IO, whether it belongs to an address lines or whether it belongs to a data lines. 3 and 5 will be enabled. So which will be disabled? 2, 6, 2 and 6 will be disabled, and 8, 7 and 8 will be disabled. 7 and 8 are disabled. So these belongs to the address lines. And now what about the these belong to data lines, and what about address lines? G. So now we want to, so 1 and 4 will be enabled, and 9 is disabled. Okay. Now let's assume another scenario. Open it. Now we study another scenario with another scenario. Now let's assume the IO device. So now we want to this. So there is an IO read operation. IO read operation. No, we already study IO read. So this is an IO write operation. We want to write some data to the IO device from memory. So क्या होगा? जी बताएं.
Sir 8
What?
or 3.
No.
8 or 5.
IO write. What? IO
8
write.
or 5.
8 or 5.
Sir 5 enable होगा.
Yes. So no. This, so we actually call it memory write. Memory write by IO device. So memory write by IO device, so actually 8 and 5 will be enabled. And basically, because we also want to provide the address, so the address will be provided from here. All of them will be separate. So now let's talk about the concept of a bus. So now let's talk about the concept of a bus. So actually, in any what is a bus? Can you elaborate a bus? What is a bus? जी बेटा बता सकता है कोई?
डेटा को ट्रांसफर करने का.
Yes. So bus is actually bus. So what I'm writing here. Bus is a channel with which multiple devices can be. Each bus has a driver. Bus has a driver and a driver है और एक receiver है. Bus should have a driver and we should make sure that only one device should drive the bus. So now let's assume a scenario. So now I'm going to have a single bus. So now let's assume this is a bus. So this is our bus. And there are 3 devices. That D1 is connected to the bus. That is controlled by the enable 1 signal. Now we have another device T2 that is connected to the bus and it is controlled by the signal T2. And now we have a third device, that device T3 is connected with an enable signal enable 3. Okay, so when now there are two scenarios. We should make sure, now if you look at this scenario, so we should make sure for this example, we should make sure that only one enable signal is high at a time. समझ आ गई बेटा नहीं? कौन कौन सी enable signal है यहाँ पे in this example?
3 enables हैं.
Enables. So now we have enable 1, enable 2, and enable. So we should make sure only one enable signal is high at a time. If two are high at a time, what's the problem? Then
short circuit.
Output will be not predicted.
Resistance.
That will mean not be predicted. You cannot predict the output. So you should make sure if all are disabled, if all of them are disabled, then
High resistance state.
will be in
High resistance.
high impedance state. When bus will be in high impedance state, it means that there is no driver of the bus. There is no driver of the bus. What does it implies? No device is having the bus with a value, so you cannot predict the output. Okay, अब बेटा समझ आ गई या नहीं जो मैंने आपको क्लास में आज समझाया?
Yes, sir.
Okay.
Yes, sir.
Okay. So okay, now I will also explain this with an example. I will also explain this with an example. An example. Sure. Now let's assume a scenario. So now you have, आप लोगों ने देखा था कि there was one signal. यहाँ पे there were two tri-state buffer. आपको याद आ रहा हो इस तरह के tri-state दो बफर थे यानी मेमोरी के लिए. याद आ रहा है या नहीं आ रहा?
Yes, sir.
जो हमने एग्जांपल किए, if you see the example आपको नजर आ रही है, ठीक है, ठीक है. These two devices are bus, and let's assume we have this is okay. This is enable 1 and this is, let's assume, enable 2. Okay, when enable 1 is high, so whether it's a read operation or write operation?
Right.
It's a write operation.
Right.
Okay. So this operation, whenever there is a write operation, so this value, whatever the value is on the bus, will be written into a write register. We call it as a write register. There may be a small register within a memory. We call it as a write register. And whenever microprocessor wants to read some value, so this is called as read register. So when enable 2 is 1, so this will be a read operation or write operation? रीड ऑपरेशन।
Yes, sir.
अच्छा, अब लास्ट टाइम आपको याद है कि वी स्टडीड वन सिग्नल, वी स्टडीड वन सिग्नल। कौन सा सिग्नल था याद है जो हमने मेमोरी सिस्टम डिजाइन में किया था? देयर वाज एड्रेस लाइंस, डेटा लाइंस, ठीक है, चिप सेलेक्ट सिग्नल एंड रीड राइट बार सिग्नल। याद आ रहा है या नहीं आ रहा?
यस सर।
कौन सा सिग्नल था जो जो रीड राइट ऑपरेशन को कर रहा था? रीड राइट बार। जी, when read write bar is 1, so what does it means?
Read. Sir,
Read
read. Read.
It's the read operation. And when read write bar is equal to 0, then
Write करेगा
Right.
sir.
Right operation.
राइट ऑपरेशन। अच्छा, अब मुझे ये बताएं कि which signal, अच्छा कब if I say read write bar is equal to 1, it's a read operation, and read write bar is equal to 0, it's a read operation. So हमें करना क्या चाहिए? Which signal should be connected to enable 1 and which signal should be connected to enable 2? How we can connect it to enable 2? जी भाई, डिजिटल लाइट आप लोगों ने नहीं पढ़ी?
पढ़िए सर।
हाँ तो बताएं ना। Now let's assume this is a read write bar signal. So where should I connect it? It's a very simple design, beta. It's a very simple design.
enable
If
1 और enable 2 में
if I directly connect it to enable 2, when read write bar is 1 is equal to 1, enable 2 will be 1 and it will be a read operation. बेटा समझ आई या नहीं समझ आई?
सर ये
Yes, sir.
थोड़ा नीचे
Sir,
कर दें
repeat
सर,
करें।
या थोड़ा जूम आउट कर दें।
अच्छा चलो मैं zoom out कर देता हूँ। When read write bar is equal to 1, enable 2 will be 1 and it will directly read the data. नहीं समझे बेटा?
यस
और
सर।
अगर हम अच्छा, अगर हम उसको कनेक्ट करेंगे इसके साथ, अगर हम इसको इन्वर्ट के साथ एक इन्वर्टर लगा लें यहाँ पे, और इस इन्वर्टर को इनेबल 1 के साथ कनेक्ट कर लें, so now there are two possibilities. Read write bar is 1, so read write 1 is 1, then enable 2 will be 1 and it will read the data. When the read write bar is 0, enable 2 will be 0, but then it will be 0 or 1 and then we can perform a write operation. बेटा समझ आई या नहीं आई समझ?
यस सर।
So this
Yes,
is the way, this is the way that how you can design a system based on a single, because now tri-state buffer has two directions. One direction is inwards to the memory and other direction is outward to the memory. The direction that is inward to the memory is intended for a write operation and the direction that is outward from the memory is intended for a read operation. Now we have to enable signal. We have to enable signal, but we don't want to enable them at the same time. यही तो हमने कहा था ना कि so what we can do, so we have defined one signal read write bar. So when read write bar when read write bar is 1, it means it's a read operation. Enable 2 should be 1 and enable 1 should be 0, and when read write bar is 0, enable 2 should be 0 and enable 1 should be 1. And then this is a simple design that how we can play, we can use a single inverter to perform this read and write operation, and then we can decide the direction of the data. So when there is a write operation, okay, now when there is a write operation, so whenever there is a write operation, the data from the bus, so आपको शायद याद है हमने पिछली दफा हमने किया था, so the data from the bus, let's assume the value is 55, the data will be written into the write register, and this data lines is multiple bits. यहाँ पे तो हम we are only studying a single bit tri-state buffer ना. Let's assume if the size of the data is 16 bits, so how many tri-state buffer we need?
So 16.
16 multiplied by 2.
32.
Because if the bus size of the bus is 16 bits, so we need 16 tri-state buffer for the write operation and 16 tri-state buffer for the read operation. If the size of the bus is 32, so we need 32 tri-state buffer for the read operation and 32 tri-state buffer for the write operation. समझ आई बेटा?
Yes, sir.
Yes, sir.
Is there any question? Is there any question? Did we need to elaborate? Any questions, beta? जी बताएं बेटा.
No, sir.
If there is any question. So now in order to elaborate further, we studied a tri-state buffer, and a tri-state buffer can be used to connect multiple devices to the bus at the same time, and you should make sure that only one device should be connected to the bus at a single time. Okay, now let me elaborate this with another example, simple examples. So let's assume you have a class, okay, a class, and then this is a data. This 1, 2, 3, and 4, 1, 2, 3, and 4. These are seats. Okay, now if you look at here, how many seats are there in the class? 16 class. So this is student 1, student 2, student 3, student 4, and 5, and this is student 16. So now this is a bus. So this is bus 1, bus 2, bus 3, bus 4. So we have now defined some addresses. This is row 0, row 1, row 2, and row 3. And if I say, I'm the teacher, and I say, okay, students from row 2, from row 2, please come here. So what we do? Okay, now this is a bus. With this bus, only one student can pass. So only one student can pass here. One student can pass here. So what we'll do? So student 8, student 9, student 10, student 11, and student 12 with the ID, they will come on the bus. Student 9, S9, S10, S11, and S12. So what is the size of the bus in this particular example? G.
4-bit.
4-bit. It's the size of the bus. 4 bits in it. And now we have a bus. This bus is shared across multiple rows. Now in this particular example, we have 4 rows. Only one row can be enabled at a time, and there can be multiple bits. Okay. So now, this bus can also be used for a read operation, or this one can also be used for the write operation. Now this is a read operation or write operation? जी बताएं.
Read.
It's a read operation. So now what can be the write operation? I can ask, say, okay, so
Go sit there.
Go and sit there. So actually the direction will be in the opposite direction. So this is a write operation. So the students who will be standing here, they will again sit on the rows, and the old value will be overwritten. बेटा समझ आ गई बेटा? यानी जो I already explained it with an example of a class and something. समझ आ गई बेटा?
Yes, sir.
Yes, sir.
Okay. जी बेटा, any questions? Any question? If there is any question, please let me know. Stop recording.